For those of you who aren't involved or might not know what it is, so the goal of ChargeX is it's a 2-year consortium that's bringing in industry, funded by the U.S. federal government, with the goals of that any driver, any EV, any charger can charge the first time every time. So we brought together a lot of industry folks to work together and come up with trying to solve some of the issues that primarily around reliability and charging reliability. Knowing that it's a multi-stakeholder process, trying to bring everybody into the same room, gets everybody speaking the same language. So overall, the goal here has been to aid the industry to improve the driving experience, especially from public charging, with the research priorities directed by industry partners themselves, who are the stakeholders in the consortium. We've collaborated together with about 90 plus companies and organizations, and have started pushing some of the work that we've been doing out through some different standard organizations. And this has been going on since 2023, and we're wrapping up this phase of the project in June of this year. And then our initial goal was to just primarily focus on charging reliability, but we're expanding that for the rest of this year to focus more on VGI tasks to improve the charging experience in addition to just the charging reliability of public. So I'm not going to go through this, but just to give a sense of like who all is involved in ChargeX and what parts of the industry. So we've tried to kind of spread across the entirety of the industry and get stakeholders from every different aspect in the area. So lots of companies up there, including lots of folks that are here today. So initially, the scope of the work was kind of broken into 3 major groups. So defining the charging experience. So, what is the charging experience? What are the metrics needed to define that reliability of charging? And then how do you develop and verify these implementation of these metrics? The second kind of stage was then looking at the reliability issues that are currently existing today. So there were 3 main areas of focus: so payment and user interface, communication, and hardware. So the payment and user interface, there was a report that came out, but we didn't do a whole lot additional work just because that kind of fell outside of the realm of the national labs. But there is ongoing work within the communication work and the hardware. So in communication, I can go into a bit more of that if you have interest. I have some backup slides, but looking at timeouts, the length of time to start a charge, ESDP protocol, and communication of errors across that, etc. On the hardware side, there's been a lot of work looking at adapters and durability of those adapters and things like that. So NREL the National Renewable Energy Lab, has been leading that effort as part of ChargeX and working very closely with UL to come up with some testing protocols to make sure that the adapters are meeting safety and durability requirements. And then the third thing is kind of looking forward. What are some of the solutions for scaling reliability? And so focusing on diagnostics and interoperability and testing methods. And so the labs are producing recommended practices and prototype tools, and hoping, and we are seeing this, that industry are adopting and picking up some of this work and moving it forward. So just kind of an overview of kind of how the ChargeX consortium is organized. So there's executive advisory board, which is industry members, leadership teams, and then we have our lab leadership team, and then we're getting some insight from state agencies as well. And below that are these different areas that I just kind of went over. So the KPI task force was that first kind of tier, and then the hardware and communication task force were the second tier, and then the diagnostics and testing task force was that third tier. And then smart charging, or vehicle VGI, is not really technically a task force, but kind of another area of focus that we'll have moving forward. And as I had mentioned, that payment aspect had been discontinued last September, and then this KPI metric task force has been pushed towards the SAEJ 2836-5 committee to continue that effort and standardize the work that was put together by ChargeX. We have a number of other reports out there, but I just pulled out the 6 that there might be 1 or 2 more, but the 6 that I know that touch on OCPP. I know you all are mostly interested in that, especially since we're here with OCA. So we have the minimum required error codes and the implementation of those error codes that was all developed around OCPP. And those error codes have also been put into Everest as well. And I believe in the public version as of today. Then the minimum required diagnostic information. This is a new report that came out in January. This is looking at, co-identification and passing of errors to try and help both the EV and the EVSE communicate an issue and help it make it easier to identify when and where that issue occurred. We're hoping to do some demonstration of this effort moving forward this year with actual hardware to demonstrate how the minimum required diagnostic information could work and why it would be valuable. There was a demonstration of that in Everest over in a simulated ESDP at the last testival in San Bernardino in November. And then there is a report from that testival from June. There will be another testival report from the last testival in November that will be coming out in the next couple of months. And then we have the KPI, the key performance indicator documents. So there was the high-level report, and we have an implementation guide that's purely focused on how do you calculate a subset of the full set of metrics we identified only using OCPP. So we have methods for 1.6 and 2.0.1. So, like I said, I have some additional slides if we have time or there's interest of what has happened to date, but mainly wanted to focus on our biggest focus for the next 6 months moving forward, which is looking at VGI projects. And so we have that communications task force that's going to be demonstrating pilot wake through the AC communication. So everything we're going to be focusing on for this year at least will be level 2 and PWM or scheduled charging through 15.11.8 and OCPP 2.0.1. So there'll be some demonstration of what can happen or how it can be implemented today with the existing standards and hardware within the communication task force. But then we have 4 additional groups or tasks that aren't necessarily in the task force that we'll go through in more depth. So the first one is mapping the V1G state machine and sequence diagrams. The second one is similar to the key performance indicators that we came up for the charging experience and reliability, but this will be focused more on essentially all the stakeholders that are tied into VGI and also, but primarily just focus on level 2. And then doing some reliability assessment of a few different charging use cases for level 2 scheduled charging to see where failure points are, where standards might be lacking, et cetera, to try and get ahead of the curve and identify areas that need improvement. And then finally doing some benchmark pilot wake testing with a wide number of EV makes and models. And so just some background information here, where we're at now on VGI1, which is the sequence diagrams. I'll do my best to talk to these. Argonne National Lab is leading this effort within the ChargeX consortium, so they would know more than I do, but I'll give the high level here. So to date, the PWM control sequence diagrams are more or less completed, as well as the state machines. The next step, we'll take this information most likely to the communications task force, to the ChargeX members, to say, hey, did we miss anything? If so, let's fix that. And then once that is done, we'll have a report that publishes these results. The next step that they're going to be working on is the scheduled charging, so coming up with those sequence diagrams and those state machines as well, and get those approved by the consortium as well and publish that all together. Next, as I mentioned, so we'll be coming up with performance metrics. I am leading this effort as it kind of complements the work that we've done on the KPIs for the charging experience, coming up with different metrics that make sense from the different stakeholders. So a bit more complex than just charging reliability, where we could focus just more on the driver, the EV and EVSE, but looking at all the different pathways of communication pathways, et cetera, and coming up with metrics that make sense for a variety of different stakeholders to try and get ahead of the curve and have industry, the different stakeholders have ways to measure the performance of VGI. And then the third one is a reliability analysis with the primary focus on as of right now, the 3 use cases that are highlighted in green. So looking at, VGI cases that are trying to assist with transformer load conditions, day-ahead pricing, and time of use random. So basically sketching out what communication protocols are needed to achieve these 3 use cases, and then identify different where issues might be where things might be missing, or where issues might arise in certain scenarios. And so this work builds off of VGI 1, so taking those state machines and sequence diagrams and building that out even more to other communication pathways from the utilities and et cetera. And DJ can talk more to this because he's been more involved in that work as well. And then finally, the EV benchmarking. So Argonne National Lab is going to be leading this effort from the lab side, but essentially trying to benchmark 80% of the EVs that are available in the U.S. and to take a look at developing a test plan and testing the charge control accuracy and precision, see what happens with PWM-based charge control response, and then also look at what EV pilot wake response is. So looking at will vehicles wake up after sitting idle for a long time to a signal that is sent over to them. So these tests will be completed over the next couple of months, and again, a report will come out that touches on the findings of this work. And then finally, as I talked to a little bit, the Communications Task Force will do somewhat similar work to the VGI Task 4, but looking at pilot wake, so looking at to accelerate the smart charge management, and looking at, within ISO 15118, currently is the main focus, and I've added a bit to Ed's slide. So Ed from National Renewable Energy Lab is leading this effort in the Communications Task Force. Right now we're only focused on 15118, but he asked me to talk to you all today to think, should we be thinking about looking into OCPP as well, or should we primarily focus on 15118, so that, happy to have that conversation afterwards to see what all you all have to think about that. And with that, I'm going to hand it over to DJ and let him go through his slides, and we can discuss more afterwards.
Very good. Thanks, Casey. So I think there's 2 things that I will take from Casey's presentation. The first sort of focus that you may have heard is that on the VGI side of things, a lot of the focus this year is on AC level 2 charging, and it's a place where we have a little bit of justification to do on the OCPP side, because obviously that's a market where hardware is a little bit resource constrained, and so we're trying to sort of work through in our heads how we can justify OCPP to improve the L2 charging experience, as well as give us these managed charging capabilities. But why level 2 charging? Because moving back to sort of our strategy at the national scale, we've modeled our charging picture for 2030. So in 5 years in the future, we expect level 2 charging to be where we have the maximum sort of scheduled charging capability, load flexibility. So this is a picture from an NREL report, where in terms of our infrastructure, 5 years in the future, we expect the vast majority of ports to be L2, both on the public and on the private side. And then modeling the flexibility that we expect to have at that time, you can see very clearly here, both in terms of gigawatt hours per hour flexibility, as well as ability to mitigate peaks. L2 is where it's at, or that's what we expect the future will be like, so which is why we want to focus on that in the near term. And that's where we're at. So Casey pointed out that a lot of the focus in the next 6 months is on pilot wake, and the reason for that is pretty clear. A lot of the sort of public L2 experience and the managed charging happens with the pilot signal. And so the current landscape is one where the driver has the minimum sort of like role to play in this infrastructure. We have several implementations. So the next few slides is just going to give you like a sort of a top-down view of managed charging as it stands right now in our thought process. So mainly this is to get input from you. When we sort of, through various outreach events, we have sort of interacted with the thousands of utilities in the United States, and we have seen several different managed charging implementations, and a vast majority of them either do a DR, a demand response, or some sort of like day-ahead rate that gets communicated to some infrastructure. There's minimum driver engagement in this process. They show up at a public charger, they plug in, they get the charging rate they see at that time. It can vary day to day, depending on whatever the building management system tells them the charging rate is. And the goal is, in the next 6 months, if we can, at least in our own heads, identify ways to improve managed charging experience for individual EV driver, and trying to identify where OCPP fits in that puzzle and how it can help us improve the experience for a driver in understanding what they can expect when they show up at a public charger, how the rates may be different from the previous day, tariffs might be different from the previous day, and when they can expect to be charged. So here are some hypothetical future scenarios, and you guys can criticize as you feel like. The first case that we often get told is communicating day-ahead prices to a driver, because in a lot of the sort of behavior-focused modeling that sort of economists do, they have a very good model for elastic demand. So essentially, if a driver knows ahead of time how much they can expect to pay, and if they can plan their day, plan their route, and pick chargers based on price, giving them some tariff information, communicating sort of day-ahead prices to a driver is one of the sort of absolutely necessary steps that we hear often come up in conversations with utilities, and that's something that we want to enable. So where does OCPP fit there? I mean, we don't know. I mean, a lot of this is based on 201, but so, and also I'm not an OCPP expert, so which is why we're here. So the goal is we want to communicate a time of use price to a driver, and in a couple of cases, utilities have asked us, is there a way for us to confirm that price to a driver so then they know ahead of time that they're going to pay this rate, they show up and they're guaranteed that rate. So can we work tariffs into reservations so that we can then predict forward and then offer them a price for showing up at a certain time of day, and can they lock that price in? Is OCPP critical to this? Can we work this into the reservation feature, for example? That would be a cool thing to try. It's one of the sort of hypothetical cases we want to explore over the next few months to see if there's a way to do this. The next thing is mid-session rescheduling. This is another very sort of like actively discussed topic among utilities here in the United States anyway, which is that people show up and they start charging, and there's somewhere during a long charge, this is L2 charging, so very long charge sessions with long dwell time, that's assumed. So if there's a feeder congestion avoidance signal, a tariff, whatever the mechanism is, if there is a need to change something in terms of how much they're paying for energy, is there a way to transparently transmit that information to the driver? Effectively, this is the K15 use case in the OCPP spec. It's something that we have found is not very often implemented. And so that is another like example that we want to flesh out in the next few months as a way of showing that a feeder congestion avoidance signal can be transparently communicated all the way to a driver, and they are aware that while their vehicle's charging in the parking, in their airport parking, the tariff has changed, and if there's a policy in place, if they accept their vehicle to stop charging or start charging, it will respond. That's just K15 for those of you that already know this. The next one that it came up in, I guess, Lanika's presentation, so I'm happy to see it, which is a lot of questions about site control or local control, as it's called in OCPP. Basically giving the local controller some agency in implementing charging policies, and this comes from a lot of interest with building energy management systems to implement like different policies, either sort of random load control or first come, first serve load control for EVs, or even have sort of EV specific policies. So to implement that, a lot of the building energy community has a sort of a stake in this, and they've been asking for a sort of a harmonized way to implement some building energy management systems and integrate that with charging infrastructure. And I think in the previous Plugfest, there were some BEMS folks, Honeywell was there, and they were talking about this thing. So, but we've, in the last year, since the last Plugfest, this has been one of the sort of most commonly asked question for us, at least as we sort of go out to the industry and talk to them about what they need. Harmonizing the sort of charge control system with building energy management has been a pretty major question. And then the last one, which is also one of the use cases, is the local transformer, load control capabilities. Essentially, having your DMS system or your distribution transformer management system communicate some sort of transformer alert that you see over here, all the way and execute that in a way that an EV driver is aware that a local transformer issue is going to rapidly drop their charging rate briefly or for some duration of time. And when you look at the user experience, what we'd like that to be like, or the way it should be, is that when you plug in and when you start your session, you have to be aware that there is an expectation that transformer constraints may interfere with your charging schedule over the next X hours. And then if that transformer emergency does happen and they have to drop your charging rate, that you get that information without having to sort of download an app and be connected to the, some sort of alert system, which is the way it is right now. And here, I think we think OCPP has a very significant role to play, which is why it's one of the objective functions, as Casey pointed out, that we're trying to identify and map out with both OCPP and 15.11.8, so that we can flesh out an example where a distribution transformer alert signal gets propagated through all of the different protocols and then eventually communicated to the driver. And that's, I guess, just K11. That's just effectively the K11 use case in OCPP, so that's why I have it up there. As a way to get started, though, we decided to implement 2 of these things on Everest today. So Shankari is back there implementing this. One is the distribution transformer emergency case. So we just wanted to see if a charging station were to send a notify charging limit request. So if some external entity applied a PMAX and you wanted to communicate that to a CSMS, would you see a response from a CSMS, and what the landscape is right now? So that's what's going on back there in the table back there. We just send a notify charging limit request up to a CSMS, and we see if they respond with anything, if they update their charging profile or what their response would be. We don't even really have a sense for what the response should be, so that's why your input would be valuable. The second thing that we're doing back there that we implemented in Everest today is, I'll just start with the second one here. It's a case where, again, you have an external PMAX limit, and we're just going to ask CSMS participants to ask for a get composite schedule request and then send a composite schedule response, because from just anecdotal sort of conversations, we find that many implementers don't have the composite schedule implemented. So we wanted to get a sense for if that's something that is commonly out there or if it's not. And then we're also looking at a scenario, similar case where if we send a notify EV charging schedule request, if the EV is responding to some, if you're plugged in your EV when you set up a policy that says, if the tariff is above this number, don't charge. So if you generate a charging profile, send that over 15.11.8, and then you send that up into the CSMS using the notify EV charging schedule request, if you get an either accepted or rejected signal back from the CSMS. So those 2 cases we're implementing. We were hoping to do something a little bit more fancier with tariffs and in the Midas rate table, but I guess it's a little bit complicated. We didn't do that yet, but the first 2 we're able to do today. So that's what Shankari is doing back there. End of presentation. Thanks. All right, there's no questions. I'll take questions if anyone has any. Cool. Yeah. I think so. I think they're recorded and they're available. They're public. Yeah.
So they will be available online. So.
Yeah.
Not today, but yeah.
Yeah. I don't know. through the, I guess, do you guys post presentations? I don't know how it works. Yeah.
If you find that, we can post them in the app.
But we can also I can just share it with you.
Yeah.
If you want to give me your card or something, I can share it to you that way as well. So.
Works. Yep.
Mark, and a question. You had a question whether you are able to communicate the tariff back to the user, to the station. That is possible in 201, and in the authorized response you can send a text description of the tariff back to the user, so there's possibility of that. And I also know that in many of the use cases, it's very important to notify the driver that something is going on.
Yes.
What I've seen until now in many smart charging or curtailment use cases, I mean, it simply happens and the driver is not notified because in many cases you might not even know who the driver is because you may have his ID token, but you might not have his email address. And also in many cases, these vehicles nowadays have an app and the vehicle itself will already tell the user that something is happening. So I wonder, is it really so essential that you're able, that the operator is able to contact the driver?
I will say that in the VGI, because this is ChargeX, this is charging experience, very early on, the number one complaint that we heard as a customer experience is the transparency. In the 6 aggregators that we have like engaged with, their number one issue is that customers disenroll because they see a variation in their charging rate and behavior based on some policy they have no visibility on. So as a consortium, national lab, government sort of group, we were requested to focus on that part of the picture and let like industry deal with the rest of it and find ways in which we can improve transparency to an EV driver so that regardless of which charging network they're plugged into, wherever they are, they get some visibility into the sort of policies at play. Mm-hmm.
Send a message to the driver, so it's responsibility to check, forward that message to the driver, that we don't have where he is at and how did he discover it. At least in the next version was behind it, but we just send a message to the driver.
That's actually.
Of course, the chain is responsible for getting the message. Most is the MSP now, so that's.
So to that point, like I think one of the questions that is in studying the reliability of like this system, the link back to the driver is the optional link that doesn't seem to need to exist for most of the other stuff to work. Yeah, exactly. So that's another question of like how integral is that to the overall ecosystem? We have engaged with one particular aggregator that you will know the name of, but I won't mention, that has a large number of EV OEMs in it. And they want to protect the customer experience because they think they know their customers really well. Yeah. So they want to protect their customers and curate their experience with managed charging. And so they do have an OCPI feed into their aggregation service. And they are really interested in having a standard way in which complex managed charging schemes are communicated, so then they can present to their customers only the ones they think are good versus bad versus and allow their customer to enroll or disenroll on the spot, which is. It's their prerogative, they think that's very valuable to their experience. So, yeah.
Also experienced missing that statement, so I pushed to get notified driver.
Yep. That's very good.
At least the CSMS can push that statement wherever it's done.
Interesting. Okay.
It's now not possible.
Mm-hmm. Yeah, and then the other sort of like big picture request has been reducing the number of apps you have to download on your phone. So we know that majority of customers have an EV OEM app, like their vehicle app. So then having all of the managed charging data available to them through their OEM app, which is another like commonly requested feature. So which is only possible if we standardize out of this messaging, because then we can then have the EV OEMs implement those features on their apps, which is another big factor. Anyway, yep. I think that's everything. Cool. Well, thank you, everyone.